label independent?
No.
I reread it.
It's very different from independent. To be honest, if you're one, you can't be the other one. That's a good enough selection. So, real quick, just to review. Independent. It's like freaking independent. It's like the word banana. Why does it stop? Banana. So how can I tell if two events are independent? What's the test for independence?
The probability is the same.
Which probabilities? That's the most important thing, is which probabilities have to be the same. So A and B. For A and B to be independent, what must be true? I'll get it started. The probability of A has to be the same as... No, that doesn't make any sense.
Probability of A and B.
I really want you to make sense. What's the probability you got an odd number on a die? 50%, right? What's the probability I randomly pick a dude from the class next door? 50%. Are you guys with me? They're the same. Does that mean they're magically connected somehow or related? No, that means shit. Dice and your gender. Thankfully, they're not the same.
Probability of A, probability of A.
Yes. Please let this make sense. The idea of independence has to do with how they affect each other. You can't look at each probability separate. You got to look at one versus how it is affected by the other one. If this is true, B happens and A doesn't give a shit, right? Whatever the probability A was, it's the same as the probability A given B happens. So does A give a shit about B? No. Therefore, they would be called independent. If this is not true, then B happening changes A probability, so they would be dependent. Please let that make total sense. Does it? It just does.
Yeah, he said.
So if these are equal, that means that if B happens, right? This says given B, then A doesn't care. Because the probability of A would still equal the same probability A, even though I know B happened over there. Right? Alright? So, what's the probability I don't know, that my car battery dies? I don't know, something, right? You with me? Now, given that the price of tea in China went up by 10 cents, what's the probability now that my car battery... Should they have any effect on anything? No, so they would be independent. The probability would stay the same. The probability of my car battery dying would stay the same, even though I knew the price of tea went up. You know, that would be really weird. The price of tea went up, damn, you know. So, given that B happened, does A care? If it's equal, it doesn't, so it's independent. If these were not equal to each other, then B happening changes the probability of A, so they would be dependent. Dependent does not mean you need one to have the other one. That's silly. Doesn't make any sense.
So is that where mutually exclusive falls?
No, don't even. No, we're not even to mutually exclusive at all. Has nothing to do with this.
So that's what was
Just hang on.
Okay, got it.
All right.
So B happens, A changes.
What does it mean if that's true? That's the question. You can't just say if B happens, A changes.
That's what it's dependent.
What is this saying? If B happens, then the probability of A change. No, that's what this is saying. That would mean they're independent because A didn't give a shit that B happened. Do you see how that makes... That's a beautiful thing to call it then. Right? Are you dependent on your mom when you're 1 month old, or whoever's your caregiver when you're 1 month old? Yes. Right? Now, does that dependence ever really go away? No. No, but you get more and more independent over time. So if something happening or not happening changes the other guy's probability, that's dependent. Okay, so that's the idea of independent or dependent.
You would just
right?
put some of the line.
Yeah, dependent, you would actually give me some numbers though. Don't just say this, back it up with some evidence.
So for the dependent, the probability of A is not equal to the probability
probability.
Totally, yeah. If to be independent, this must be true. Then if this is not true, they must be dependent. I like it.
Can you say like a car battery T definition for dependent?
Like an example. All right, here's a good one. All right. Here's one we could see happening. We can actually calculate probabilities. You ready? Hopefully everybody wasn't lying to me when you said, nobody said they weren't at all good with cards, right? So help me out. What's the probability, if I pick one card, what's the probability I get a king? We did this yesterday. 4 kings out of 52 cards. Cards? Where are you from, Jeff? Sorry. And what was that? 0.076? No. 0.076? Yes. Okay. I'm decent with numbers, so I sort of know. All right, now, that's just the probability of king. I didn't tell you anything, right? So if I pick a card and I look at you, I'm like, you want to put money on this being a king? Well, what's the odds it's a king? What's the probability? 452, right? Okay. Now, what if I picked a card, looked at it, and said, this card has a face on it? Does the probability it's a king change? Why? Now, show me. So what am I going to analyze now? What did I just tell you about the card?
That it has a face.
Has a face, right? So I'm still wondering about what's the probability of king, but now knowing that it has a face. So look at me. Now, how many face cards are there?
Jack, king.
There's 3 per suit, 4 suits, 12. I like it. So what's that got to do with anything? Given that it's a face card, how many cards could it be? 12. Out of those 12, how many are kings? 4. What's that? 1/3, 0.3333. Did the probability change?
Yes.
In fact, it went way up, right? So if I'm going to put money on it being a king, and I happen to notice in the mirror it's a face card, I'm like, I feel better about that bet. My probability that I'm going to get money has gone quite a bit up, about 4 times. Yes, maybe, no?
So
Yes.
in an example like that, given that it's a face card, they like remove the rest of the cards in the deck.
Yeah, because you throw out all the cards that aren't face cards. So are king and face card, are they independent? Hell no, because if I know it's a face card, does the probability of a king change? Shit, yeah. Do you see how that makes sense to call that dependent? What's the probability it's a king? Well, it depends on if it's a face card or not. Oh, let's call that de-frickin-pendent, because that's the word we just said. Yeah.
So for that case, like, is that saying that since it's 1/3, if you pulled it 3 times, like, you're going to pull it at least once?
No, I love that question. All right, real quick, since you brought this up. What's the probability I flip a coin and get a heads? For one flip, what the shit does 50% mean? Doesn't mean a damn thing. So the idea of probabilities and percentages really only makes sense if I do something a lot. So if I flip a coin 300 times, then I could say about half of them should be heads. Then the 50% makes sense. Are you with me? Completely forgot your original question, but that was the point I wanted to make.
Yeah, that was it.
All right.
And how would you write that? Like yesterday. you
Oh,
were like-
so king and face card are dependent, since the probability of king does not equal the probability of king given face card. 0.076 does not equal 0.333. This, please just don't memorize this shit, but that's what I need to see when I ask you. Are they independent or dependent? This is an explanation of how they are dependent. Let me show you a situation that's independent. You ready? I love you guys. I'm taping this too. Remember I put them on the YouTubes, on the internets? All the videos of the lectures? Okay. So, same idea here. So the probability I get a king, if I pick one card, is 0.076. What's the probability it's a king? So now I pick a card, and I'm like, oh, I'll tell you it's a club. Right? So instead of telling you it's a face card, I'm going to pick a card and go, it's a club. Does that change the probability it's a king? Let's investigate. You can't tell, because remember, our brains are not hardwired for probability, so thank God we have ways of telling. So what do I want to calculate? The probability of king, given that it's a
Well,
club. How many clubs are there?
13.
13. I don't mean downtown. Clubs and clubs. And then out of those 13 clubs, how many are kings? 1. And isn't 4 out of 52 reduced to this? What is 1 divided by 13? Same thing, of course. And what just happened? Somebody said earlier about throwing shit out. I love it. If I throw out everything that's not a club, I've thrown out 3/4 of the deck. I've also thrown out 3/4 of the kings. So all the ratios are the same. So are king and club independent? Yes. Because the probability of king equals the probability of king given club. Knowing that it's a club does not change the probability it's a king. If it did change it, then it would depend on if it was that or not. Right?
Do you have to do the math to make sure that was?
You have to.
Not do math, but you have to put it like what the equal sign.
Totally. So here I would say yes. I don't know what letter that is. Yes, independent. Probability of king equals probably a king given club. 0.076 equals 0.076. Right? I need to see the numbers so I know you didn't just memorize the definition, but you actually know what numbers to look at. Just like on the practice thing, I always A through whatever, you're going to calculate the things you need. So when I ask you the independent question, you just have to go back and find them. Or you can calculate something else if you want to and answer the question, but I'm going to make you do the work already. You just have to find them. It's really not that hard of an idea. It's one of my most frustrating things is how to say this in a different way. It totally is just, yeah, I'm going to call it dependent. If I know one happens and that changes the likelihood of the other one, I'm going to call that dependent. It actually makes sense for once in math, the word we use. Okay. Anything else from homework stuff or general ideas? Yes?
Can you do an example where you give us the numbers and we need to use the formulas?
Oh, okay, let's do, well, number 4 on that practice quiz is perfect for that, right? It's a freaky-ass problem. So I don't know if you guys have tried that out yet. You're all like, dude, man, no. But let's do this. Well, if you have tried it, just sit there for a minute, but so everybody's got the practice double quiz, right? So go ahead and try out number 4 on there if you haven't tried it out yet. No. So I wish I would have changed. So tomorrow's thing is a double quiz. Corrections are always due the day of the next test. You could turn them in early. That's beautiful. But not due till the next test. Oh, that's my fault. That's right. I forgot that. That would make all of these wrong. Right? But unfortunately, your mistake requires you to redo this. You know, so you're right. That's correct. But then all these should change too. Well, no, you got that graded. Yeah. By the way, normally after the double quiz, when I give that back to you, I also give you a grade sheet summary, so you'll know what your average is. Or you could just come to my office, that's way right there, and sit down and take a look at your grades. Either way. Okay. What's the test for independence? give you everything you need. No. I already told you the probability. What are you going to compare that to? No. That doesn't matter. So, how do you check to see if A and B are independent? Probability A has to equal probability of. No. You did this whole thing. To be independent, the probability of A must equal the probability of A given B. Otherwise, they're dependent. And I give you those two numbers. Yep. Thank you. Oh, I never did talk about mutually exclusive, though, did I? So all mutually exclusive is a much simpler idea. I used to use dog and cat. And this is kind of dating myself, but oh well. Then this cartoon came out. Cat dog, yeah. The biology of that is like human centipede kind of thing, but I don't want to think about it. Alright. So now I use so mutually exclusive. What does exclusive mean? What's the root word of exclusive? Exclude, right? So an exclusive place would be like, could I walk into any restaurant, I want you dressed like this? No. They're going to exclude me in some places if I don't have black tie and jacket and stuff, right? Or just because I'm me. Or like a country club is exclusive, right? Or something. Mutually is both sides do it to each other. It's like, oh, you don't want me? Well, I don't want you. Right? That's mutually exclusive. So, for example, if you are a rock, can you also be ice cream? No. I don't care if it's ice cream shaped like a rock. Then it's not a frickin' rock. I don't care if it's a rock that looks like an ice cream cone. It's not ice cream, right? If you are one, you cannot be the other. So if A and B are mutually exclusive, what is the probability of A and B? 0. You can't be both. That's the fundamental idea of mutually exclusive is you can't be both. So the and will always be 0. What's the probability if I pick up one thing? What's the probability? It's a rock and ice cream. 0. If it's a rock covered in ice cream, don't give me that shit. Just please, dear God. It's a rock or it's ice cream. Alright, keep going. So that's a little bit easier than independent. That's very straightforward. They can't both happen. That's all mutually exclusive means. Well, what do you need to calculate to be able to answer this? About like A and B. And you have a formula for that. You guys can use your notes, obviously. This is not the quiz yet. What formula? Which part are we doing? It's not a formula for A, it's an idea. How do I check to see if two things are independent? I check to see if this equals that. Do they equal each other? What do you mean you guess? Yeah, so not independent. They're dependent, yeah. It's that simple. So I already did the work for you in that one. You just got to compare. Oh yeah. Part B is where you need to calculate something. Yes.
Can I just see if I'm writing this right?
You have this written in your notes somewhere. If answering this question requires you to know what the probability A and B is, maybe you should calculate it. And then see what happens, right? And this is a formula we talked about yesterday. So,
I was going to say no.
yeah, for part A, it's no. Yeah, it's yeah, Probability of A is not equal to probability of A given B. I like.
Say this right. Just like this.
No. No. I don't compare A and B. Because the idea of independent is how do they, if they affect each other. So if I just look at the probabilities separately, how is that looking at how they affect each other? So what probability is about mixing the two? This one.
How's that
So if I know B happened, this is probably a change. Look at it. Probability of A is what?
0.8.
What's probability of A given B?
Oh, 0.
So if you know B happened, the probability of A goes up. So they are dependent. That really is all there is to it. That's it.
Wait, so would it be probability of A is not equal to the probability of B given A, or A given B?
Why would you compare the probability of A to the probability of B? I want to compare the probability of A to the probability of A. In this case, I happen to know that B is true.
Okay, so
These are both probabilities of A. This one is the probability of A given I know B happened. This is just the probability of A by itself. So if they're different, that means that B happening changed the probability of A. So I'm not comparing A to B. That doesn't make any sense. I want to compare A to if A changes when I know B happened. I want to see if it does change.
it doesn't.
If it doesn't change, then they're independent. They didn't give a shit. If B happens and these are the same, A didn't give a shit that B happened.
So this one isn't.
Are these different?
A and A?
A and A given B.
No.
What's the probability of A?
Probability of A is between A.
What's the probability of A given B? Are they the same?
Oh, no, they're different.
Okay. Look at the numbers. No, wait, you don't know this. No, that's A given B. That's not A and B. What's the smallest it can be, and then that says what is it? Okay.
Okay, so I get your analogy that you use for restaurants, but how would like a number be say like, hey, I don't want you in the soda number sound?
What?
Like for mutually exclusive.
If the probability of an event changes because I know something else, then those two things are dependent on each other. So the probability that there's an accident.
No, I get that. I'm saying for mutually exclusive.
Oh, mutually exclusive. What about?
Yeah, I get how you use
There's no
the-
numbers there. I mean, it's can these events happen at the same time? Can you be a female Democrat? Of course you can, right? So therefore, females and Democrats are not mutually exclusive because you can be both. Can you be a Democrat and a Republican at the same time?
Well,
Identified on your political party slip? No. So those are mutually exclusive.
okay. Okay. So you can't be. See, that's what was confusing me too, because I was looking at the numbers and I was like,
Of course. So what's that mean then about the probability of A and B? Which means, what's the probability of A and B means? It means that A and B happens at the same time. So if you have A and B and they can't happen at the same time, what's the probability of A and B? 0, because they can't happen at the same time. So I pick up an animal. What's the probability? It's a rabbit and a hawk. 0, because you can't be both at the same time. So how do you check it mathematically? Does the probability of A and B equal 0? No. All right, guys, let's take a look at this. Can somebody just tell me, what does or basically mean? Add. What does and basically mean? Multiply. I like it. Will you always do that? No. If I have a situation I can count shit, I'm not going to use any formula. I'm just going to count shit. Right? It's only a problem like number 4, the one we're doing right now, where you must use a formula for sure, because you got nothing you can count. All right, so what do you guys get for A now that I pretty much walked that one through a few times? What do you check for part A? You check this.
probability of A is probability of A.
And they're not equal to each other, right? So they are dependent. Now, real quick, somebody remind me, what's the formula for probability of A given B? Right? That's the formula. What's that?
So when we take this next test, is that going to be like a formula we can write down, or is that?
Yeah, the next thing after this is we're going to make a formula sheet so you can bring it tomorrow. Okay.
Oh.
So again, no words except, and. You can't identify next to it, use this when, blah, blah, blah. No. So I'm going to tell you exactly what's allowed in your formula sheet. Anything else, you lose points, right? Everybody understand that? I always get somebody like, oh, you lost points? No, of course you did. I told you you would. You have a whole example. Oh, man. Now, watch. If they are mutually exclusive, what's this? 0. So then what's this? 0. Is this 0 for this problem? No, it's 0.85. Okay, so part B is no. It can't be, because this can't be 0. Now, I will not ask you a question like part C. I won't. Why'd I put it on here? Because we're exploring ideas. I'm not just getting you ready for tests. No matter what you think or what you think I should be doing, too damn bad. Right? So this is a really cool idea. Any probability I calculate has to be at most what? Any probability I calculate can be at most what? 1. If I calculate a probability and it's over 1, I don't circle that and give it to me. Give it to teacher. Here you go, teacher. The 1.7, 170% chance. Get out of here. Right? You figure out what the hell went wrong. So, watch this. So part C, I give you a hint. I say, look at this. Look at the formula for this. Oh, get out of there. Right? So start to fill this in. What's probably of A? What's probably B? And I don't know what this one is, do I? Well, what do I get so far? I get probably of A or B equals 1.2 minus something. If this was 0, if that were 0, what would I get for the answer to this probability question? Holy shit. So what's the smallest this can be to bring this back to good.
0.2.
There you go. I like it. Are you ever going to see that problem again? No. Does that mean some of you guys are like, why the shit are you making me do this? And I don't care. We're exploring an idea. That's the main thing I'm supposed to do with you.
You said that in the topic.
Certainly. So I give you this clue because it's definitely something that you would never really think of yourself. And I'm not saying anything bad about you. It's just weird. But if you try to calculate the probability of A or B with what you know, this number by itself is too big, right? So this can't be 0. What's the minimum, what's the maximum accepted number this could be? The probability at the end, 1. So how do I make this become 1 if this is 0.2? All right, so that's what part C is all about. What's the smallest this could be is 0.2, because anything smaller makes this probability illegal. Now part D, I say, actually freaking calculate it, and that's why I put this formula up here. Where do you go here? So what do you get in part C? The probability of A, I'm sorry, was it C or D? D. The probability of A and B. What do you guys get? Oh my gosh, Jeff. Yeah, it'd be what was B? 4 times 0.85, right? 0.4 times 0.85. Who is it?
0.34.
Point?
3, 4.
Okay, all right. Okay. Was it, and does it match with what we said earlier? Yeah, the smallest was 0.2, and it's bigger than 0.2. Does that make sense? And now what do I need to figure out part E? What's the formula for this? Whenever I ask you a probability question, and I give you nothing to count, write the formula. So then you can just see, do I have everything I need? So what's the formula for B given A?
Probability of B and A divided by the probability of A.
Yeah, totally. Do you have all this shit? Yeah, I know the probability of B and A. 0.34. Is everybody cool with, I could just turn this around, of course? The probability of Steve and Tom versus Tom and Steve, same freaking people. So it'll be 0.34 divided by, you know the probability of A from the beginning, 0.8. That's 0.4 something.
425.
0.425? So if I have a situation where I don't have things I can count, they just tell me the probability of C is 0.7, the probability of D is 0.3, and then they ask me a probability question, I'm going to write the formula down and see if I didn't know this, I would calculate it. If I didn't know this, I'd calculate it. Because I know I need them. Yeah?
For the wording on like the mutually exclusive problem, do you just know they cannot be mutually exclusive, and then the probability that A or B is not equal to 0, and it's all numbers?
Yeah, that's fine. Here, I'll give you the answer. I decided to give you a break from my handwriting on this. Oh, yeah. Nick, right? Yes, sir. Sure. See Ramla. Leslie. is the that's the bond.
Is there some homework you want to already have it graded, maybe yet?
Homework?
Yeah.
Oh, hell yeah. Don't think I'm a miracle worker with grading homework. Holy shit. I'm not really near done with that. That can still be discrete. I mean, what's the idea of presence of that? So like gas station price, it has decimals, but it doesn't matter. It skips. Right? Aw. That's too good.
Test question.
Oh, definitely. Yeah.
That's where we get it.
Remember, if you give me homework on the day of the test, you'll get it back someday before the final. If you give it to me before the test, you'll get it back by that day of the test or before.
Now I'm just trying to, 'cause I want to try it.